Hello everyone, I'm Bhuvan hosting. First thing, whenever we think about research, we want to do watershed delineation, right? And then there's a lot of programming, there's a lot of user interface that we have to come across. But what if you could do all of those things in a single interface? Today I'm going to talk about that. So there is something called PyGILE Plus. This is you can you can access this using this link. Here you will find QGIS, SAGA, GraphGIS, WhiteboxTools, Orfeo Toolbox, and a lot of Python packages already inbuilt in a Dockerized environment. It has like thousands of packages already inbuilt inside this system. So what we can do, how we can use it, I'm going to show it like easily. First thing we need to do is go to Docker Desktop using this link, download for your whatever I mean, the operating system you have. For me, it's Windows. You download the executable file, and once you install it, will come something like this. And once you open, it will pop up something like this. So here, this is mostly about like, here it might be like in the original files, but what we need to do here is cd into the file that we want to work on. But what is the file? What is the folder we're going to work on? This link, PyGILE Plus, first we'll download this in a zip. And when we go there, it'll be something like this. When we unzip it, it will pop up something like this, let's say. So this thing you will not find inside. This is, let's say, your sample study. While downloading, you will only get this. Inside this, you will have README, algorithms, Docker, and example notebooks, right? So what we need to do is read inside Docker. So you can open from here, or I'll just, so it's easier, I'll just open this one. It's the same thing. So to run all of these, everything that's inside this package, just Docker pull Dockergile and this into this Docker Docker desktop. So if you don't see this terminal, it could be something like this. Just click here, the terminal will pop up. CD into the folder that you have just cloned. So for me, this is the one. I'll just copy and then CD into that folder. Now it's there. Now just paste. Now just paste the the pulling command that is already a pre-built image in Docker Hub. You can just paste and hit enter, and something like this will pop up. This is like inside the images, you have just created an image. Now you need a container to work on it. So to create a container, there's another link given here. It's Docker run and then name of the container, the port, and the volume. So you can mount with that particular address in the workspace and give the name. So when you run that, for instance, let's say when Docker run and the name of the container, let's say the name of the container, let's make it a little bit shorter, and volume is the place, let's say for now, sample try, and the port, this volume, and the folder that we have the data on, and the workspace, and from where you're going to download it. Just hit enter, and inside this containers you'll find that a new container will be built, right? So this is the new container that's been built here. So what we need to do is just click on this port mapping, and it will take us to Jupyter Lab, where all of these things will be available. Now let's say you have a digital elevation model of a particular area that you're trying to work on, right? So let's say inside this sample study, I've got this. These are things that we already have from this thing, so I don't need to put them again in that thing. So I'll just remove it for avoiding the confusions here. Let's say I'll remove this 3 and remove these 3. Let's say you have a distal elevation model you have a save file of a study area, right? So now what you need to do is just copy that folder and put it inside the cloned PyGILE Plus, right? Now, if you go to Jupyter Lab, you will see the folder pop up here, right? So just open it and you can see your files. Now, what you need to do here is, it's simple. It's simple as it sounds. So let's say watershed analysis. For this, we have a watershed analysis JSON file. So the main code, we don't need to do anything with that. There's a JSON generator. Here, all you have to do is just specify the path of the DEM. So where is your DEM? So for me, I just go here, this double click, and this is my DEM. So I just copy the path and then just replace the paths here, right? So all I'll do is run, it's run, and let's check. And inside this notebooks, this 8 seconds ago, a new JSON is created and it should have my new DEM, right? That's all. That's all for now. Then all we have to do is run this watershed analysis. Go there and no need to change anything here because the JSON will cover everything. So when you run, shift enter or this, so now it will show the digital elevation region. For instance, let's say for this region, somewhere around, let's say, okay, here, in this there's a bridge. Let's say I want to know the watershed of this region. So there's when you click here, it will come latitude, and here it will be a box that will appear, and just copy and paste the latitude and hit enter. Similarly, for longitude, just copy and paste, or you can just type also based on your preference and then hit enter. So if it's not correct, write no and then retry. If it's okay, then type yes and hit enter again. And then wait for some time, and the watershed from this particular point that you have selected will be delineated for this particular DEM that you have given us your study region, right? So let's wait for like a minute or something, right? Yeah. So this is the watershed of this particular pour point, right? So and you can see the results here. So this is just the start, right? Now you've got the study area. Now you can work in any way possible, any way you want, right? So why I'm saying that is because all the QGIS, SAGA GIS, Grass GIS, WhiteboxTools, Orfeo Toolbox, and thousands of like core libraries of Python, everything is here. You don't have to go anywhere else. Just figure out what you want to do and then you can just do it. Just in this Jupyter notebook, after creating this, everything is there. So this is one of the convenient methods that you can utilize. You know, no issues with the environment setup, no issues with all those conflicts of system-based libraries, the core languages that conflict with like pip versionings and all that. This is a Mamba-based environment. It's created in such a way that the Docker image contains all of those packages, and there'll be no issue at all. You can just run smoothly, and it's a headless container. And even these kind of analysis you can do, for instance, like in QGIS, it looks like this. In Saga, Grass, like it's the same thing using this them. We just did like slope for using all of these, uh, what do you call the GIS softwares that usually you have to open QGIS like this and then you start doing it, right? You can do it. I use this for visualization as well, but a lot of times I want simplicity. I want things to like to be easier, so you can do like this. So thank you so much. I hope this is informative and useful.